In this video, you're going to see how to multiply radical expressions. Okay? In other videos, we saw how to simplify radical expressions when you just had one radical or maybe a coefficient in a radical. Here you're going to see multiple radicals and multiple numbers to multiply together. It's really not too bad to do. Basically, the whole concept is to just multiply the numbers outside the radical by themselves, and then multiply the numbers underneath the radical symbols by themselves. And then if you can, simplify the radical, just like we did before. Okay? So in our first example, we see 5 square root of 2, or 5 times the square root of 2, times 3 square root of 6, or 3 times the square root of 6. Even though there's no time symbol in between these, it's assumed that you know that it's there. So basically what I just said, multiply the numbers outside. Okay, so 5 times 3, you're going to get 15. 2 times the square root of 6. Now, there's really two ways you can do this. You can just multiply them together and get the square root of 12. And then you could factor square root of 12 like we did before. The other thing you could do, if you wanted to, you could break down the square root of 6 into its prime factorization. Well, I know that 6, if I break that down, I'm going to get 3 times 2. And those are both prime. So this really says 5 times 3, that's 15. Times the square root of 2. Times 6. But I'm not going to write 6 as 6. I'm going to write it as 3 times 2. Okay? I got the 15 by doing 5 times 3. This 2 is this. And 6 became 3 times 2. The reason I'm doing this is because this way I'm not going to multiply these together and then factor. I'm not going to, it seems like too much work to multiply and then factor. There's really no point. I'm going to make more work for myself. I mean, especially since this 2 is already prime. So now, this might be a little easier. I see a 2 here and a 2 here. Well, if I see 2 2's underneath the radical sign, I know I'm going to get rid of both of them and put 1 2 out front. So this really says 15 times 2. And then since the 2 2's left, I'm left with a 3. Where is this? 15 times 2 is 30. 30 times the square root of 3 is the same thing as 5 times 3. 5 square root of 2 times 3 square root of 6. It's the exact same thing. Okay? We're done. We're going to try this again. Same idea. Now I've got negative 2 times the square root of 5 times the square root of 45. This time there's no coefficient for the square root of 45. Since there's no coefficient there, let's assume that you know that it's 1. So negative 2 times 1, that's just negative 2. Anything times 1 would just be that anything. Let's see. I've got the square root of 5 here. That's as simple as that gets. That's prime. 45, though, that can be broken down. Let's see. 45 is going to factor into, well, 9 times 5. 5 is prime, but 9 is not. 9 can be broken down into 3 times 3. And those are prime. Let's put all these numbers in here. Okay, this 45, this part here is the exact same. But now I'm putting the 45 under the same radical. And you can do that. Okay, so 3 times 3 times 5 takes the place of the 45. 3 times 3 times 5. And again, for every pair of things under the radical, pull a pair out. Okay, get rid of the pair, put one of those numbers that were in the pair out front. I see a 5 and a 5. That pair is eliminated, a 5 goes out front. So negative 2 times 5. I see a 3 and a 3. That pair, I get a 3 out front. Now there's nothing left under the square root symbol. I could write it, but there's nothing underneath it. Okay, so you don't need anything. I mean, if you really wanted to, you could say there's a 1 there still. But the square root of 1 is 1. That's not going to have any effect. There's no point. Okay? It's gone. So negative 2 times 5, that's negative 10. Negative 10 times 3, that is negative 30. And I guarantee that if you type on a calculator negative 2 times the square root of 5 times the square root of 5, you should get negative 30. Let's see just to make sure. I'll show you. You should see it right there. Negative 2 square root of 5 times square root of 45 is negative 30. Now, I will want you to actually show me how you got this most of the time. Like in this case, you can't just type this in here and get this answer. Okay, 30 square root of 3, that gives you a decimal answer, so you won't want to do that. It's like 40 something, 40 close to 50 probably. Actually, probably over 50. Okay, last problem. Same idea, but now there's 3 things we're multiplying. 8 times the square root of 6 times 3 times the square root of 12 times 5 times the square root of 2. Okay, well we're going to multiply all the coefficients. 8 times 3 times 5. Let's see, 8 times 3 is 24. And 24 times 5, that should give me 120. Yeah. Square root. 6. That's not prime. So I need to break that down. 6 breaks down into 2 and 3. So in place of the 6, I'm going to write a 2 and a 3. 12 isn't prime. So I'm going to break that down into a 3 and 4. 3 is prime, but 4 is not. Breaks that down into 2 and 2. Okay? So the 6 became the 2 and 3. The 12 becomes a 3, a 2, and a 2. So times 3 times 2 times 2. 2 is prime, so I'm just going to put that extra 2 down here. Okay, so 120 times the square root of 2 times 3 times 3 times 2 times 2 times 2. This is all under the square root sign. So let's see how many pairs I have. I've got a 3 and a 3. That's one pair. I've got a 2 and a 2. I've got another 2 and a 2. Everything pairs up. So just like the last one, the square root symbol is going to go away entirely. And that can happen. Let's see what we get. We get 120 times. Well, I paired up a group of 3s, so times 3. Paired up a group of 2s. There's my 2. And I paired up another group of 2s. Okay. Now all that's left to do is to actually multiply. Let's see. 120 times 3 is 360. 360 times 2 is 720. And 720 times 2 should give me 1,440. So in 2 problems here we got regular numbers, numbers without radicals. And that can happen. It won't always happen, but sometimes it does. And again, I'll show you just to make sure that we get the same thing. 8 times the square root of 6 times 3 square root of 12 times 5 square root of 2. We do in fact get 1440. Okay, exact same thing. And that's what you should be able to get. So for any of these problems, once you finish, make sure you type in the calculator, make sure that the end is the same as the beginning. And just out of curiosity, I'll check the first one just to make sure that it was what I said it was. What did I say? It was going to be somewhere around 50. Yeah. Square root of 2 times 3 square root of 6. Okay. So that first answer was 30 square root of 3, and that was from 5 square root of 2 times 3 square root of 6. You see that both answers there give me pretty much the same exact decimal. Well, actually not pretty much, exactly the same decimal. That's how we know it's the correct simplification, or that it's an equal simplification, I should say. It might not be the most simple. In this case it is, because 3 can't be broken down any further. All right. That's basically all you have to worry about in terms of multiplying radical expressions, for my class anyway. There are other things that you can do. You can have fractional things, but that's the same deal. In another video I'm going to show you how to rationalize denominators when you have a radical in there. And that should do it for this video. If you have any questions or comments, leave them in the box below. I'll be sure to get back to you as soon as I can. And I hope you have a great day. See you around.